In order to understand how a hypervisor works, you need to know how operating systems manage the underlying hardware. Think about a simple application task like Open Cloud Academy website or print a document. If you want to browse our website, your browser application has to use the network card and it has to make a system call, in order for that to occur. Some operating system components can directly access your hardware. In order to manage these different privilege levels, modern x86 CPUs have different execution privilege groups called rings. Each ring has different restrictions on the type of operations that can be performed by the CPU. For example, device drivers and the kernel usually run in ring 0, which grants the highest permission level, while user applications always run in the least privileged ring. This also applies to virtual machines themselves. Virtual machines require an operating system, and this OS requires ring 0 authority. As a guest OS is unable to access ring 0 directly, it must obtain ring 0 privilege through a complex workaround. Hypervisors usually solve this problem with either para or full virtualization. In the para virtualization method, when a privileged command must be executed on the guest OS, it is delivered to the hypervisor through a hypercall, a kind of system call, and the hypervisor receives this hypercall, accesses the hardware, and returns the result. Para-virtualization requires some modifications to the guest operating system kernel in order to use the hypercall mechanism. Thanks to hypercalls, virtual machine applications and operating systems run in CPU ring 3, the least privileged CPU mode. Full virtualization provides a complete simulation of the underlying hardware, allowing the execution of unmodified operating systems into virtual machines. It requires that every salient feature of the hardware be reflected into every one of several virtual machines. In full virtualization, machine language code of the guest OS is converted into the machine language code of the host through a binary translation process. Unfortunately, the speed reflects this additional step. CPU manufacturers provide a variety of functionalities to reduce full virtualization overhead at the hardware level. A CPU supporting hardware-assisted virtualization additionally provides ring -1 level, and the hypervisor runs on this ring while the guest OS runs on ring 0. Consequently, it essentially circumvents the binary translation process for privileged commands, and each command is executed directly on the hardware via the hypervisor. Thanks to CPU virtualization instructions, the performance gap between the full virtualization method and the para-virtualization one has been significantly reduced. Here you can see a recap of the pros and cons for both techniques.